the idea is about is that the derivative of f of x is equal to the limits of f of x plus h minus f of x all over h as h tends to 0. So this is the idea that we're going to be embarking on. So what does this mean? We're going to substitute. Wherever we have x, we're going to put x plus h, right? So here we have x plus h, we're going to square that, all right? And then plus 3 times x, but it is x plus h. So this is the idea that we have. There's a minus 2. And then we're going to subtract the f of x, which is the entire thing. Now we're going to subtract this entire thing, which is 2x squared plus 3x minus 2. So we're subtracting that, and this is all going to be over h. So basically what we want to do at this time is that we want to carry out our algebra. So we're going to first square this. So basically I'm going to square x plus h. So it's going to be x squared plus, multiply this and then double. So we're going to get 2xh, square this, plus h squared. And that's for this part right here. Then we're going to distribute this. So we have plus 3x plus 3h. There's a minus 2 here. And then this negative sign here will be distributed throughout. So it's going to be negative 2x squared, negative 3x plus 2, and all of that will be over h. Now we're still going. Now what we're going to do here is that we're going to distribute the 2 inside. So now we'll have 2x squared plus 4xh plus 2h squared. So we distributed this 2 inside. We're going to write back these. So plus 3x plus 3h. And then let's write back everything. It's minus 2x squared minus 3x plus 2. And this is all over h. Now, when we do that, we're going to realize that there are some things that we can actually cancel, or some things that will actually cancel out each other. For example, we're looking at this negative 2x squared. We'll get rid of the 2x squared, right? We're also looking at the fact that this positive 2, get rid of that negative 2. This 3x, get rid of negative 3x. So then we had gotten rid of those, right, terms that become 0. We're going to rewrite this to see what we have. So let us rewrite this. We have 4xh plus 2h squared plus 3h, and that's what we actually have there, and all of that is over h. All right, so we're going to take our time and still go through. Remember though that we're dividing by h here. So what we're going to do now is to divide all of this by h. So excuse me just to put this beside here. So we're going to have 4xh, this is going to be divided by h. The 2h squared will be divided by h. The plus 3h will be divided by h. So right here, we actually just divide this h into all those terms there. And then let's cancel to see. So the h cancel here, the h cancel that, we're leaving with h here, and then these cancel here. So let us now just write back to see what I really have left. So what I really have left is I do have 4x, I should say. So I have 4x coming from this part right here. And I do have 2h, so I have plus 2h plus 3, right? So this is what we have left. So everything is equal to that. But please bear in mind that, remember that we are actually taking the limit, right? Where h tends to 0, right? So if we're taking the limit of h as h tends to 0, you're going to realize that right here, right here, as h tends to 0, that h is tending to 0, which means that what we really have left here is 4x plus 3, because this h will become 0, so it's no longer there. So basically then, we are at the end where we can say the derivative of f of x is actually equal to 4x plus 3, right? So we can see that using what we call the definition of a limit, which is to have taken the limit of as h tends to 0, should say, is h tends to 0 of f of x plus h minus f of x all over h. So using first principle or the definitions of limit, that would be your answer. Thank you.